All right, in this video, we're going to look at double angle formulas. So double angle formulas allow us to find the sine, cosine, or tangent of 2 times an angle once we know information about that angle. So you have 3 equations here. Cosine of 2a has multiple equations. I'll talk about that in a second. But your equations for double angle, sine of 2a equals 2 sine of a times cosine of a. Cosine of 2a, there are 3 formulas, cosine squared minus sine squared. Notice that these are all equivalent to each other because of the Pythagorean identity. Sine squared plus cosine squared is equal to 1. And so all of these are just rearranging the same equation using the Pythagorean identity. So you don't have to know all 3 of these. You could use whichever one you prefer. A lot of times we end up using cosine squared minus sine squared because we're dealing with fractions, and that'll end up with the same denominator, so we don't have to worry about a common denominator. And so it really doesn't matter which one you use. You can use any of those, but all 3 of those equations are equivalent because of those Pythagorean identity. Tangent of 2a is 2 times tangent of a over 1 minus tangent squared of a. We actually could see where these double angle formulas come from using our sum formulas. Think about, let's just start with a basic easy one. Maybe if I can get my pen, here we go. So let's think of sine of 2a as sine of a plus a. Think about our sum formula. We could rewrite this as sine of a times cosine of a plus cosine of a times sine of a. Those are the same terms, aren't they? So if we add those together, we get 2 sine of a cosine of a. You can see the progression of where those equations come from, and that works for all of them. We could set that up for all of those. I'm not going to go through that with you, but you could see from your sum formulas that that's where those equations come from. All right, so let's talk about using these equations and how we can find different values. This is going to look really similar to the second part of our sum and difference video, where we're given some information about an angle, and then we're going to try to find the double angles, sine, cosine, and tangent. Okay, so let's say that they tell us that cosine of a is 5 over 13, and a is in between 3 pi over 2 and 2 pi, so it's in the 4th quadrant. And then they want us to find all 3, sine of 2a, cosine of 2a, and tangent of 2a. So we're going to go through all of them, but before we do that, we do need to make sure that we find our different values. Think about what we need. For each of these equations, we need sine of a, or cosine of a, or tangent of a. So we need those values to begin with. We already have cosine, but we're going to need to draw a triangle to figure out what those other values would be. Again, this is in the 4th quadrant, so here's our triangle. There's our angle A. Cosine is 5 over 13, adjacent over hypotenuse. That's a well-known triple, 5, 12, 13, so the other side should be 12, and it will be negative because it is going down. So then we know that sine of A is opposite over hypotenuse, negative 12 over 13. Cosine of A is adjacent over hypotenuse. We already knew that one, 5 over 13. And tangent of A is opposite over adjacent, negative 12 over 5. Now, we're going to be able to use these values in our equations. So let's say that the first thing they want us to find is sine of 2a. Okay, so that formula, sine of 2a, is 2 times sine of a times cosine of a. So let's plug in the values that we found. We said that sine of a was negative 12 over 13, and cosine of a was 5 over 13. So now as we go to multiply out, 2 times negative 12 times 5. Remember, 2 is like 2 over 1, right? So we're only multiplying the 2 by the top. So 2 times negative 12 times 5, that would be negative 120. And on the bottom, 13 times 13, 169. Does not reduce, so negative 120 over 169 is the sine of 2a. And again, no calculator needed. We could do all that using just our right triangle and getting those values and then plugging in. All right, let's try the cosine one. Let's say we want to find cosine of 2a. I'm just going to use that first equation, cosine squared of a minus sine squared of a. And again, doesn't matter. You could use any of the three, but personal preference for me, I like to use the cosine squared minus sine squared because we're dealing with fractions, and that way I already have a common denominator. Think about why. Cosine is adjacent over hypotenuse, so your hypotenuse is the denominator, and it's going to be squared. Sine is opposite over hypotenuse, so again, your denominator is going to be hypotenuse squared. So you have the same denominator automatically when you use this version of the equation. So just a little bit, goes a little bit faster. Okay, so cosine we said was 5 over 13. So we have 5 over 13 squared minus, and then sine we said was negative 12 over 13. And we have that squared. So 5 over 13 squared, 25 over 169, minus negative 12 over 13, when we square that, 144 over 169. Okay, if we subtract, we already have a common denominator. 25 minus 144 is negative 119 over 169. Okay, so that's cosine of 2a. Now let's talk about tangent. Let's find tangent of 2a. Let's use our equation. It's 2 times tangent of a over 1 minus tangent squared of a. So let's plug in. Okay, we said that tangent of a was negative 12 over 5. And then we have 1 minus negative 12 over 5 squared. All right, so let's keep going. 2 times negative 12 over 5. Again, 2 is like 2 over 1, so we're only multiplying the top. That becomes negative 24 over 5. Then on the bottom, we have 1 minus negative 12 over 5 squared. So we have 1 minus, what is that, 144 over 25 when we square. So negative 24 over 5 all over. Now, on the bottom, if we get a common denominator, we've got 25 over 25 would be 1 minus 144 over 25. That would give us negative 119 over 25. Okay, let's flip and multiply. We want to multiply by 25 over negative 119. Our negatives will cancel because we have a negative divided by a negative. 25 over 5 would become 5. And then 24 times 5 would be 120. And our denominator would be 119. Now, something I do want to point out. Think about our quotient identity for tangent. We know that tangent is equal to sine over cosine, right? So we could also say that tangent of 2a is equal to sine of 2a over cosine of 2a. Let's think about the values that we just got. We found those in parts A and B. Sine was negative 120 over 169. And cosine was what? Negative 119 over 169. If we flip and multiply, we're going to cancel our negatives and we're going to cancel the 169, and we'd end up with 120 over 119. We would end up with the same thing. So if you're already finding sine of 2a and cosine of 2a, you can just divide those. Okay, but not every problem is going to ask you for both of those. So I just wanted to make sure that we talked about that using the actual tangent formula as well. Okay, that's what we want to do every single time. Draw your triangle based on where the angle is. Draw in values based on the trig function that they give you for information. At the beginning of ours, we had that cosine was 5 over 13. Drew our triangle, labeled everything, and then found our 3 trig functions that we might need for our equations. Once we do that, we can then plug into any of the equations we might need to. In this case, we worked it out with sine of 2a, cosine of 2a, and tangent of 2a. Found all three of those. Once we found those values from the right triangle, easy to plug in.